So let me first welcome you all.
Sir,
Uh,
sir, 1 minute, 1 minute.
yes.
Okay. So 1 minute, sir.
So
So,
let me
uh,
first welcome you all.
sir, 1 minute, 1 minute.
Yes.
Sir, I'm audible.
Yes.
Okay,
So
okay, okay. Sir, good morning from India. Distinguished professors, a warm wishes to all of
yes.
you. As a organizing secretary of IGU India International Conference Virtual 2020, I'm delighted to welcome you all respected dignitaries, Professor Fausto O. Sarimanto, United States of America, Director, Naturotrophical Montology, Collaboratory, the Department of Geography, University of Georgia, USA and Ecuador. Professor Jun Mauso from Japan, Professor Department of Geography, Tokyo Metropolitan City, Japan. Professor Soresni Sen Roy, Professor University of Miami, USA, United States of America. Dr. Pankaj Kumar Sir, Secretary, Commission of Mountain Studies. All of you, warm welcome. Now its platform is open for discussions. Please, most welcome to start for your discussions. Thank you so much.
Thank you. Thank you very much, Bhavar, for inviting giving us a space in your conference, the Mountain Commission. I would like to welcome formally each panelist here. Please make me the host. As you can see here, first I would like to welcome the chair of the session. My screen is going on well.
Yes.
Okay. So Professor Fausto O. Sarmiento is the full professor and director of Neotropical Montology Collaboratory Department of Geography, University of Georgia, Athens, United States of America. He looks into human-environment interactions informed by evidence of landscape transformation and dynamics of land cover, land use changes with critical biogeography, political ecology insights, historical documentation, neo-ecological field research, and modeling for alternative scenario of sustainability and regenerative development. He was regional editor for Latin America for the Journal of Mountain Research and Development and is an editorial board member of Annals of AAG, Pinos and Journal of Mountain Ecology and the Journal of Mountain Science, China, and also in the Journal of Parks of the World Commission of Protected Area of IUCN. He is board member of the international program of Satoyama Initiative of United Nations University Institute of Advanced Studies. He was a steering committee member of Commission on Mountain Response to Climate Change of IGU and former president of Andean Mountain Association. He is co-chair of Latin American Caribbean Mountain Research Network. Currently, he is chair of the Commission of Mountain Studies of IGU, International Geographical Union, and deputy chair of Mountain Specialty Group of WCPA and member of Protected Landscape Specialist Group of at IUCN. So, Professor Sarmiento, you are welcome. The next one, the moderator of the session is Professor Jun Matsumoto. He is the Director, Research Center of Climatology and professor in the Department of Geography, leading researcher, Tokyo Metropolitan University, and also visiting principal scientist, DCOP, JAMSTEC. Our member of the session is also Professor Swarasini Sen Roy. She is now our alumni of Department of Geography, Delhi School of Economics. Now she is professor in Department of Geography and Regional Study of University of Miami. Her research and teaching interests center on climatology, spatial analysis, and crime patterns. Her work focuses on a spatio-temporal pattern of climate processes across various regions, including the Indian subcontinent, South Africa, China, and USA using advanced geostatistical techniques to analyze trends in climate variables. In addition, she has recently started working on crime patterns in South Florida. Her research projects include impacts on global telecommunication on summer precipitation in India, trends in the occurrence of extreme precipitation events in India, impacts of cloud cover on diurnal temperature ranges, spatial characteristics of urban heat island, air pollution in Delhi, Hong Kong, and Beijing. Her research has been published in International Journal of Climatology, Physical Geography, Monthly Weather Review, Geophysical Research Letters, and Journal of Geophysical Research, Weather and Climate Extremes, British Journal of Criminology, European Journal of Clinical Policy and Research, and the Professional Geographer and Allied Geography. I welcome Swarasini Sen, ma'am. Thank you very much for joining us. And then we have another Dr. Sandang Ing Anglong. He is the lead researcher in the Department of Social Geography, Mongolian Academy of Sciences, working basically on environmental impact assessment area. You all are welcome. And now I request Professor Fausto O. Sharmanto, chair of the session, to take over the session. Thank you very much.
Thank you very much, Professor Kumar. If you don't mind, stop sharing your screen.
Yes.
Very good. I will welcome everybody. I am very happy that today we are having this important session under the title of Crisis in the Studies of the Interaction between the Highland and the Lowland. And because of this new phase in which mountain studies have actually emerged recently, I am delighted to incorporate this notion of mountains in crisis. Oftentimes, we are exposed to the notion that in order for us to study mountains, we have to take a look at this very dangerous place outside of our immediate urban flatland space, oftentimes thinking that what is happening up there is going to influence negatively on what's happening down here. And so because of this crisis mode, we have often been afraid of looking at the mountains as a friendly place. Oftentimes, particularly in the post-colonial geography, we didn't realize that the European eyes who first described these mountains had given us the impression that we have not been connected with the mountains as the native people have in the past. This is what I have studied in Latin America, in the Andes Mountains, whereby the work of Alexander von Humboldt on Mount Chimborazo, the idea of geoecology was born. The notion that vegetation zones are located in altitudinal belts that can be easily identified with some indicator species. Also, animals tend to go into these altitudinal belts. So this Humboldtian paradigm had become the standard for understanding mountains. A faraway place in the hinterlands where people have really very little influence, thinking that just the climate, particularly temperature and precipitation, drives the presence or absence of some specific plants and animals. Nowadays, we have taken a different view. We are following Edward O. Wilson from Harvard University in his idea of incorporating different viewpoints from different scientific venues in order to understand what he calls consilience. Consilience is a new term, a bit difficult term to understand, but it is a different way to say transdisciplinary science. We in university settings have always been studying mountain geography from the disciplinary view, meaning that we only have one single optic. Nowadays, particularly after the creation of the Commission of Geoecology within the International Geographical Union, and then the transition with Professor Jack Ives and Professor Bruno Messerly, who indicated the idea of the interaction between the highlands and the lowlands, this topic of at least multidisciplinary view of the mountains became really important. Nowadays, the funders of research, the donor agencies who are fueling research around the world, are incorporating the requirement that you will have some interdisciplinary work done, not only climate has to be understood about the mountains, but also the sociology of the place, the archaeology of the place. Nowadays, in this next step, mountain geographers are looking into a transdisciplinary approach of science, meaning that the Western science that had given us the positivistic science is only one way to get to know the mountains. We also have to take a look and to listen to other avenues of knowledge, such as, for instance, Eastern science, or the traditional ecological knowledge, the local people's view. In this new era of transdisciplinary work of mountains, we are committed to take away the idea of crisis in mountains, to incorporate this view that mountains are part of us. We are dealing with what we call manufactured landscapes. Culture and nature together have created a hybrid landscape in which these situations that in the past were considered crises are often a reflection of a mismatch between the symbiosis that we have between nature and culture. It is this reason why I was really very happy to attend the cordial invitation of my colleagues in India for their Geographical Congress, because India, as you know very well, is the birthplace of many things, particularly the birthplace of science. And so because of that, looking at mountain science from a different perspective is very important this time within this Congress. I welcome very much the opportunity to listen to the presenters. I welcome the opportunity to work with Professor Matsumoto from Japan, who will be moderating the session. So with my warmest welcome, I will actually like to give the word to Professor Matsumoto in a presentation of the panelists. Thank you very much for your attention.
Thank you very much, Professor Fausto Sarmiento, for your wonderful chair of the starting of this session. So can I share my screen? Or is it all right?
Yes, we can see your screen.
Okay, thank you very much. So actually, as introduced by Pankaj Kumar, I'm a chair of the Commission in Climatology in IGU, and honestly speaking, I did little connection with mountain studies, but since it's a good chance, yes, actually my studies mainly in the lowlands in Bangladesh or Assam or some such kind of states in India. And but it is a good chance for me to also I had an interest also for the highlands as well, also due to time limitation or something. I did a little about it, but I'd like to talk something from the climatological view of this high lowland interaction. And so today I'd like to talk something about recent flood situation in Bangladesh, the very lowlands, and then introduce Highland-lowland interaction in the Bangladesh to Bangladesh floods. Founder of Mountain Research Group, Ibis and Mesari, which also chairs introduced. And then I talk to something about our research in rainfall floods and rice production in the Ganges-Brahmaputra River Basin. Okay, so anyway, as many people knows, recently widespread flood disaster frequently occurs in Bangladesh, located in the lower Ganges-Brahmaputra River Basin. And such frequent flood occurrences often related to the recent deforestation in the Himalayas, which may provide typical example of Highland-lowland interaction. Okay, so this is a map of Bangladesh, and this is 1998 severest flood in the history. So you see, so this is elevation, and Bangladesh lowland region. This is Ganges River, and this is Brahmaputra River joined together, and then flow into the Bay of Bengal, Indian Ocean. Okay, only hilly region in Bangladesh is located in the southeastern part. and also in some sense here the hilly area, and also maybe this is a kind of fun area which is elevated relatively high, but others are located basically lowlands. And in the year 1998, yes, these blue areas all flooded, okay, inundated. So as such, also this is a very lowland and many waters, and also soils are also flowing to here. Okay, so anyway, if we see the longer term flood area, yeah, we didn't know how much buried it is, but anyway, this is the statistics of the Bangladesh Water Development Board. And this was starting from 1954, during the maybe East Pakistan period. Bangladesh independent from the Pakistan, maybe 1971 or 2, I don't remember exactly. Anyway, in the year 1987, at that time, the century worst flood, nearly 40% of the country was submerged. And I had a chance to visit Bangladesh and India. This was actually for the first time in my life for the overseas research, and why this kind of flood occurred in this particular year, in December 97. But the next year, in 1988, it was exceeded more, maybe 20% or much severer flood occurred. And again, 10 years later, 1998, it was more, almost 2/3 of the country was submerged. Okay, and even in the recent, some severe flood also occurred. And this is an example of such a severe floods in recent years. So you see, this is a Ganges River, and this is Brahmaputra River. And this is where maybe it's not well known for the worldwide, Meghna River. But you see here, the submerged area is very huge. And this is a Meghalaya Hill, actually, this is the rainiest place in the world. I'll talk something about this place later. Okay, so we call Ganges, Brahmaputra, Meghna River, GBM River Basin or something. Anyway, in Bangladesh, all three such rivers join together, and as such severe floods sometimes occur. Okay, so after I visited Bangladesh for the first time in 1987, for example, in the flood in Bangladesh, this kind of publication was published in 1989. So the situation is like this during the flood period. And there is a kind of a chapter showing the cause of flood. Okay, so anyway, there are some common causes and also uncommon causes. But anyway, deforestation in the upper catchment and sediment in the riverbed, this can be included, this kind of cause of flood. Okay, also heavy rainfall, of course, it is related, and I'll talk something about it later. Also flood control activities, even if the primary aim is to prevent flood disasters, but sometimes it works worse. For example, in the case of Bangladesh or such lowland. Okay, so also relatively uncommon cause of the disaster. This year means maybe 1988 in this case. But anyway, melting of ice of Himalaya or something, that are included. So this is a kind of a speculation. So we should also tackle how accurate these causes are or not or something. So anyway, during almost all similar period, Jack Ives and Bruno Messeri published a very famous book, The Himalayan Dilemma, Reconciling Development and Conservation. And maybe nearly 10 years later, University of Bellum people intensively investigate the situation in the floods in Bangladesh. and he just gave a question title of this book, Highland-lowland Interaction, which is a topic for this session. Okay, so so this is from the first book I took. I decided the necessary. Maybe there, one of the reason for the problem is the population explosion in the upper catchment area or mountain area. And then it caused deforestation, then accelerating soil erosion and increased landsliding. And then lower reach of the river, the increased flooding of the Ganges-Brahmaputra river plains, and the extension of the delta and the formation of islands in the Bay of Bengal, and drying up of wells and springs in the hills and lower drying season, river level downstream or something like that. So, or maybe this is a kind of the things or theory which mountain lowland interaction are considered in the Ganges-Brahmaputra river basin. And their conclusion is that, I did little field observation, but they did very intensive field observations and also data collections as well. And the scale is very important, from micro scale, meso scale to macro scale. And the left-hand side is a kind of human impact, and the right-hand side is a natural impact. And if the scale is smaller and smaller, then the impact of human impact effect becomes bigger and bigger. But their conclusion is at the macro level, this is a kind of minimal. Okay, so of course, these kind of things are really occurring, but this is mainly occurring micro level or just meso level near the mountain area or just close to the mountain frame boundary, not directly related with Bangladesh. So this is their conclusion. On the other hand, yes, always, precipitation is important for all the spatial scale. Okay, so since I'm a climatologist, I talk more about such rainfall situation. And this is the second book conclusive. So there's 6 theses, but I just talk 3 here. And anyway, the first thesis is the rainfall and discharge pattern in the Ganges-Brahmaputra Meghna Basin must be different for each monsoon season. And the patterns in the Meghna catchment, which are less famous maybe worldwide, seems to be the primary importance. So this is his conclusion. And rainfall patterns in the Himalayas have almost no impact on flood processes in Bangladesh. And then the Meghalaya hills, which I introduce later, will be, and also the Bangladesh itself is most relevant to the flood processes in Bangladesh. So the reason for the severe Bangladesh flood is located much closer to the flood plain. Okay, and so this is a kind of the duplication, but the Himalaya do not have any significant impact on the floods in Bangladesh. This is his conclusion. And I did after coming back to Japan, I collected rainfall data from India, and at that time it was very difficult to obtain, honestly speaking. But so in the how the rainfall situation in the 1987, I studied, and regrettably it was published in our bulletin of Department of Geography, University of Tokyo, where I worked at the time, and it was not listed in the internet, so it's not available only paper format. It's available only in format, but anyway, I just plot the rainfall distribution around Bangladesh, and at that time, I didn't get any data from the Meghalaya hill, but even we see the rainfall situation in Bangladesh, the northeastern part of Bangladesh received the heaviest So this is normal situation, and this is a situation in 1987. So you see, compared with both figures, then we see here and also here we have much more rainfall compared with the normal situation. And yeah, in Bangladesh here, Silet we call, and also the Chittagong here. So these are two wettest places, but not much for the other region. Okay, so then as I said, the following year, more severe flood occurred in Bangladesh. Then I collected these 2 year rainfall data in both Bangladesh, India, and then I wrote a paper again later in this journal. Oh, anyway, India, they have very long history of their all India summer monsoon rainfall, starting from 1871, so nearly 150-year rainfall variability have been analyzed. Okay, so if you see, the rainfall is almost, yes, so actually in India, all Indian rainfall have almost no trend during these 150 years, but still have some abundant rainfall years and also scanty rainfall years. So year-to-year variation is very huge. And in particular, for example, in 1987 and 8 are kind of peculiar years. So 1987, we have very scanty rainfall, while on the other hand, 1988 is a kind of abundant rainfall. Actually, it is maybe the highest rainfall during near recent 40 years. Okay, so anyway, this kind of contrasting rainfall pattern occurred in India, but on the other hand, both years, Bangladesh experienced very severe flood. Okay, so then this is the station rainfall station I corrected. So at that time, I also included Cherrapunji rainfall data. And then I plotted also the for India and Bangladesh and even Nepal. I included rainfall situation. And this is percent of the normal in 1987 and 88. So sorry, so it's a Vulcan fly, but this is a drought year. So this is almost only half of the normal rainfall here. So it's very dry, in particular, northwestern part of India. Only wet here, northeast, and this is extended 150% or something, okay? So although the region of the more above normal rainfall is relatively small, but as I explained before, this is a kind of the rainy, very heavy rainfall region. So this may cause a very huge amount of water to flow into Bangladesh. Okay, and in the year 1988, so you see almost all over India, except only small part here exceeding the above normal rainfall. And also Bangladesh itself received relatively more rainfall. Okay, so if you see the situation more closely to Bangladesh, then yes, now we include the situation in Cherrapunji, and you see Cherrapunji rainfall in these 4 months is huge. Okay, exceeding 12,000 millimeter. Okay, and here also 11,000. Also other hill station here in India, 6,000 or something. Okay, so compared with the previous rainfall map just drawn in Bangladesh territory, it's more huge amount of rainfall occurred in the Meghalaya here, we know. But we see in the Himalayan region, not much. Okay, of course, some rainfall, yeah, relatively more, but more rainfall occurring just near Bangladesh, India border and Meghalaya here. Okay, so and the pattern itself is not much different in the in these 2 years. Also, from if we see the more wider scale for including for India, it's very contrastive. But as for the rainfall occurring situation just near Bangladesh is not very different. But if we see closely, So here the rainfall, higher rainfall region exceeding 2,000 millimeter, extending more westward here. Okay, while it's more concentrated in the northeast. Okay, so you see the different amount in the Cherrapunji, 1,000 millimeter difference. Okay, as for Cherrapunji, it's not very much, but 1,000 millimeter per 4-year difference are quite huge. Okay, and then there are such a high rainfall amount region are in case of 1987, it is partly included in the Ganges River. So the water flowing from the Ganges River contributed a lot, of course, to the Bangladesh floods. But in case of 88, it is very limited. Although rainfall here is more importantly, Brahmaputra River water important. As such, yes, in the similar rainfall situation in Bangladesh occurred some small different rainfall patterns in these two contrastive flood year. Okay, then I just would like to introduce something about the Meghalaya situation. So sorry, this is in Japanese, but Meghalaya is here. Actually, Meghalaya is a Sanskrit word, adobe of cloud or something. I heard the geographer named this place name. Anyway, Cherrapunji is located just on the southern higher places here. Okay, and the Siret to Bangladesh and the Bangladesh India border, I will introduce you later, is around here. Hey, so Cherrapunji, and also for the rainfall, Mausinlam just west of Cherrapunji, they are also, said the rainfall is the highest here. Okay, anyway, these two places are the most rainiest places maybe in the world. So it is the rainfall is concentrated in the warm season, but it exceeds, as I showed, 12,000 millimeter per year or something. Okay, and near Bangladesh border, maybe 5,000 or 6,000 in this is average rainfall. So anyway, this is a kind of the world most rainiest place in the world. And in year 2004, this is also a smaller flood year in the 21st century. And this is a water level at Siret here. Then you see that there is a kind of the stepwise water increase. And this is a kind of danger level. So this is, also exceeding the danger level to cause severe flood in this particular place. But the rainfall situation in Cherrapunji is here. Okay, you see the daily rainfall 800 millimeter or something. So this kind of a rainfall amount exceeding 200 millimeter per day continues several days or even nearly a week or something. So this is a kind of rainfall characteristics in Cherrapunji. But you see there is a kind of a very large intra-seasonal variability. So we can say there are always monsoon rainfall are active there. And this is a longer time rainfall variation, annual rainfall starting from 1993. And this is a kind of the severest rainfall year during this period. And recently this is not much, but still the rainfall amount is exceeding 12,000. Okay, and there are 3 years kind of a flood year. Okay, so yes, it's only 1 point situation, but you see the good correspondence for the Bangladesh higher, flood area here, and these stars are indicating a higher Cherrapunji rainfall years. Okay, highest 5 rainfall years. So it's only one station data, but it implies a very close relationship between the two situations. I visited Cherrapunji in August 2004. And yes, so it says that this is the highest rainfall amount which I introduced. And also Mausenram village, this is a local rainwear, local people wearing anyway traditionally. And also they say it's the wettest places in the world. Okay, and this is a record which I was lucky to see at Mausenram station. And you see, this is the year 2001 and this is 2011. So huge amount of rainfall occurring there. Okay. I'd like to introduce some of the landscapes there. So this is such a high rainfall area. Also paddy fields here, but mainly the main crop will be the corn, I guess. This is the river or maybe the valley, not very steep. And also see the vegetation situation. So vegetation, even though it's such a very rainy place, vegetation is there. I think this is cut before. But also see the valley topography. We can see there is a kind of a steep valley here. Maybe this is related with the crust movement situation or the tectonic movement situation or something. But anyway, I need a little study about it. So it really needs a kind of interdisciplinary study with geomorphologists, but I had no chance. Okay, also the river is like this. So like this. So of course, as I see, the vegetation cover or forest cover over the hill area is not much here, but still maybe erosion not much in this region. Okay, and this is near the Bangladesh border. This is a river, and if you see from the hillside. So this is a sand river or something, and a huge number of boats. These boats, later I introduced, they are taking gravel or stones from the riverbed. Okay, so actually in Bangladesh, this is since located in the deltaic area. Stones are very precious thing. Okay, so they took stone all by hand like this. Okay, so and this is Meghalaya Hill and Bangladesh plain border. So there is this kind of a waterfall. So maybe it erodes some debris here, but this is just impression. It's not much amount of the sediments maybe transported, and you see a relatively flat topography here. Okay. Okay, and the rivers like this, and this is Bangladesh plain, and you see almost inundated in the city area. I also visited near the border from Bangladesh side 1 year before, and this is the riverbed situation. So this is almost sand with some gravels or something like that. Okay, and these people are taking stones from the riverbed all by hand, and then all the trucks will transport these stones to the other area. So this is a kind of human intervention of the maybe sediments, and actually it reduced maybe the river sediments, I guess. So, okay, this is the first part of my talk, and later I talk something about the regional difference of the effect of internal annual rainfall variation on the rice cultivation. So, as I showed to you, Bangladesh, were affected by very severe floods. But what is the effect of these floods on the rice cultivation there? Anyway, India and Bangladesh, it's a kind of second and fourth ranked rice producing countries. So their rice is very important for their economy. And if we see the rainfall situation in Bangladesh, so this is West Bengal, Bihar, and Uttar Pradesh, This is the upper catchment area of Ganges River, and this is for Groundwater area. So here we have relatively longer rainy season, and also the highest many months rainfall amount are more. So if we go northwest part for the Bangladesh, Ganges River, the rainfall amount decrease, and also the summer monsoon seasons shortens. Okay, and this is the so traditionally India, Bangladesh region, we have two season rice cultivation. One is Kharif. This is during the wet season or rainy season. We grow rice, and Rabi season. This is grow in the dry season. Okay, so these two period cultivation is common there. Okay, and we published this book recently, Rainfall Rise and Rice Production, and also other paper, rainfall variation on rice production in Ganges Basin. Okay, so anyway, in India, it is well known, this is the food grain production annually. Of course, due to the technology development, it increases more and more. But anyway, we see drop, sometimes very severe drop occur. And this is a rainfall time series, which are all Indian rainfall, which I showed before. So you see all these drops corresponding to the scanty rainfall year. Okay, and if we plot these two scatter diagram, then we have very good correlation. So if rainfall is more, rice is more. Rice here, food grain, but rice is similar situation. And the situation is the same. So this is rice situation. Rice situation is the same. And also in Thailand, the similar situation occurs. So this is a kind of common situation in the monsoon Asian country. But if we plot the same similar rainfall and also rice production in Bangladesh, almost no correlation or even negative correlation can be found. Why? Okay, so we just using the rainfall data, the graded data set, and also rice production data, and also product effect data we collected. So this is Ganges, Brahmaputra, and Memuna River Basin, which is under the West Bengal, Bihar, Uttar Pradesh, Assam, Indian states. So this is Meghalaya state and some different, but anyway, like this. And so this is maybe somewhat different on the river basin boundary, but yeah, because of the statistics, we just use this kind of information in Uttar Pradesh, Bihar, and West Bengal and Assam states situation data. Yeah, and Bangladesh, we just say two season crops, but in Bangladesh we have Kharif and Rabi crops, but in Bangladesh, Kharif rainy season rice have two kinds, Aush and the first half of the year, and among locally called. So this is the latter half of the parentheses. Okay, so yes, actually, Aush is a kind of rainy season rice, which is very popular in the Asian monsoon region. And also the bowl. So this is a level and water level lower. Then, yeah, due to the irrigation, only this kind of dry season crop can be grown. Okay, and this is a correlation coefficient between summer monsoon local rainfall with rice production. This is correlation, and red color means positive. So like all Indian situation, all these regions are positive. So if rainfall is more, we have more ice, and the vice versa in the scanty rainfall area situation. While in the Bangladesh situation, it's almost opposite. Okay, although the correlation is lower, the green bluish means so it is not related to positively related with rainfall, or even negatively related with rainfall variability. So this is very contrastive in the upper catchment area and the lower catchment area. And if we see the time series of the rice production, so total rice, if you see the total rice, so Bangladesh total rice also expanding. But if we see the statistics in Ocean, Boro, and Amon, Ocean, Amon, and Boro, then we can see the situation is somewhat different. So we have very severe flood in these years in 1987 and 8, which I introduced, and later 1998. Okay, so what is I forgot. Anyway, first time I was very surprised in these severe flood years. Bangladesh rice have almost no damage. Okay, compared with the previous years, or Indian case during the drought, it's much less, but almost no change. Oh, why? Yes, actually, in the Amon rice, the rainy season rice reduced almost without exception in these flood years. Even in the older time, drops occur. Okay, but the dry season rice after that follow, yes, it increased more than this decrease. That is the kind of the reason why the rice, annual rice cultivation or rice production does not decrease in these flat years. Okay, and also the important thing is, yeah, here after the biggest flood in the history, 1998, so water rice production exceeded Amon rice or wet season rice. So nowadays, and such situation continued after that. So even it's a relatively stable recently, such kind of a rapid increase contributing to the rapid rice production increase in Bangladesh in the first 10 decades during the 21st century. And this is an area-wise statistics. Then, yes, as I said before, Amon rice dramatically decreased during these flood years without exception. All such flood years, the cultivation area over Amon rice decreased. On the other hand, the ball rice always decreased. And Amon rice, Aush rice, sorry, always is decreasing, and it seems no relationship with flood situation. Okay, so anyway, so this is yeah, just rice yield. Yeah, maybe this is the same. Okay, and then this is also related with the high yield variety situation. So in the case of Boro, sorry, in case of Amon, high yield variety is also increasing, and local variety is very much decreasing. Okay, and this is also related to these severe flood years. Then after the severe flood years, such a high variety increase. That contribute a lot to the more rice production in the following year. Okay, in case of Boro, so as I said before, it needs irrigation. Okay, and also the irrigation area steadily increase. That contributed a lot for the increase of the rice production. On the other hand, for example, in these severe flood years, the high yield Boro cultivated area exceeded such an irrigation area. So this is a kind of speculation of our study, but in this period, just remaining water flood water, remaining flood water also may serve as a kind of natural irrigation to increase high yield cultivation area and contribute to the higher dry season rice production. Okay, just rice production situation in Bangladesh and the adjacent Indian state situation. This is Bangladesh rice situation, as I explained it, developed a lot. Yeah, West Bengal, Bihar, Assam, Indian situation also increased somehow, but it's much less. Okay, compared with the Bangladesh, yes, West Bengal also increased, but it's not much. So this is total rice production. And if we see the yield-wise, then the West Bengal and Bangladesh is almost the same. On the other hand, Assam and Bihar are much lower. Okay, and so this is Rabi or boro rice yield. Then yes, as I explained before, Bangladesh boro rice much more rapidly developed in this 10 or 20 years. But West Bengal case, it's much earlier it occurs, so-called green revolution occurred. And after that, almost constant. Okay. On the other hand, Bihar and Assam maybe recently just increased. Okay, but still in the lower level. And the Kharif rice case, so this is wet season rice. Yeah, in that case, West Bengal is at top. Okay, Bangladesh also increased, but still not much. And in case of Kharif rice, Assam and Bihar also increased. So, or maybe the situation is different in the dry season rice. So it is my conclusion. So we examined the rainfall distribution for the years 1987 and 88 during the severe floods in Bangladesh. And heavy rainfall occurred in northeastern Bangladesh and the Meghalaya hills and northwestern Bangladesh, is Indian territory just near the Bangladesh border. The effect of the heavy rainfalls for the Himalayas may be minimal. This will support the conclusion by Ives and Messeri and Fofa. Over the Meghalaya hills, the land degradation seems to be not very severe and may cause little sedimentation effects to the Meghalaya River basin. But this is just an impression I did, not detailed studies. Maybe this is needed to be verified by more detailed study. Also, we examine the long-term variation of rainfall and rice production in India and Bangladesh, focusing in this river basin. Bangladesh located in the lowermost part of the river, although severe floods occurs, their damages are not much in our annual level due to an increase of the dry season rice in the following season. And after the big floods, the rice production has increased greatly. Now the dry season rice is a major part of the annual rice production. Maybe this is the first time in the Asian rice production history that dry rice exceeding wet season rice. So anyway, as such, situation is different. Indian states, or of course, severe flood occurrence in Bangladesh is a kind of big issues for local people. But if we see the macro scale or annual base rice production, it's not very harmful so this is just my impression. So I'd like to get your opinion on it. Okay, thank you very much. So that's all of my talk. Sorry, I can't hear Chair. Maybe stop mute.
Thank you very much again, Professor Matsumoto. We need to go ahead and give the floor to the presenters. I will start inviting Professor Shurasen Sen-Roy from the United States to make her presentation. As a reminder for the following speakers, we do have a time limit, so please consider making a presentation around 15 to 20 minutes to allow some questions for later. The moderator, Dr. Matsumoto, will then actually handle the question and answer session after the three presentations that follow.
Yeah. Sorry, I took rather longer, sorry. Yeah.
In this case, let me give the floor to Professor Shurasen Sen-Roy.
Thank you, everybody. Let me share my screen here. Okay, so good morning, everybody. Good evening from here. It's quite late. Thank you for inviting me to the to this conference. Thanks to Dr. Singh for organizing to to Mohanlal Sukhadia University, Udaipur, for organizing the conference and on such an important topic. So the topic of my presentation, as I have shared before, is on the spatial patterns of the role of land use, land cover change, and seasonal level rainfall on regional level trends of groundwater in India during 2002 to 2016. My presentation very closely follows Professor Matsumoto's presentation. There were a lot of topics which are related to his presentation. So I enjoyed listening to his presentation. I'll try to keep to the time limit as 15 minutes. So let's start with why this topic is important on the topic of climate change and water resources. Water is, of course, one of the prime medium through which climate change influences the Earth system, and it will be one of the primary modes in which we will be experiencing climate change. In addition, when we talk about climate change, higher temperature, changes in extreme weather conditions, all of these would affect indirectly or directly the distribution of precipitation, which in turn can affect the surface and groundwater flows and ultimately the water quality and availability. And the impacts of climate change, there's general consensus that the effects of climate change will be felt most by the poor and vulnerable sections of the society in the developing and the less developing countries of the world. And as climate change warms, there will be alteration of the hydrological cycle. We are already seeing, especially in the tropics, we are seeing increasing intensity of extreme precipitation events. Warmer temperatures, which in turn increase the rate of evaporation and the holding pattern of atmosphere, which will again alter the precipitation patterns, long-term precipitation patterns. And this is particularly critical when we think about the tropics, where currently 1.6 billion people live in these countries and regions with absolute water scarcity. And this is only going to increase in the future to 2.8 billion by 2025, some of the estimates show. And I'm going to show you some of the maps just to highlight the importance of global water stress and why I'm studying this topic, my topic of research. So here's a global water stress shown by the World Resources Institute. And as we can see, the tropics are the most stressed areas of the world. So in the United States is the Southwest, and in India, we see the Northwest, where we see the maximum water stress. And this is an image where the groundwater depletion has been mapped using relatively recently available satellite data, GRACE satellite data, from which it shows that the Northwestern India is one of the most are one of the fastest depleting groundwater resources regions. This is a image which looks at the spatial patterns of freshwater stress, which includes groundwater between 1995 and the projected depletion by 2025, where again, the tropics show up high, and one can notice that India, actually the stress will increase by 2025. So it's only going to increase in the future. And this shows the aqueduct water vulnerability, and this again shows the same patterns where we notice the tropics. So in short, this is going to be an important topic, and if we keep on at the business as usual scenario, by 2040, this region in India, especially, which is one of the most densely populated regions of the world, the northwestern India and peninsular India is where we are going to see a lot of water stress. So having said that, this shows the resilience of the largest aquifers in the world. And I really found this image, this map important mainly because, and relevant to my case study, was we can see that this is one of the densest, most densely populated regions of the world, the Indo-Gangetic Basin. And this is a region which is also very, very stressed, or the least resilient of the aquifers in the world. Coupled with that, here is the percentage of irrigated land in the Indian subcontinent from the Food and Agricultural Organization. And again, this is the region which stands out as the most irrigated region of the world. One knows that in the 1960s, with the Green Revolution, when canal irrigation was established in northwestern India, as Professor Matsumoto was talking, he mentioned that dry season rice yield was higher than the wet season rice yield, if I heard him right. And so that directly relates to this image, which shows the amount of irrigation which has increased, the percentage of land irrigated. So India has moved from a rain-fed agriculture to irrigated agriculture. So our yield has increased, but at what cost? And here is a series of maps which are created by the World Resources Institute, which I thought very well captures the topic of water stress in India. So 54% of India faces high to extremely high water stress. When we talk about highland-lowland interactions, the Himalayas, which are located out here, they are considered to be the world's highest water towers. And they can only keep supplying water up to that point, beyond which it's not possible to increase. And then, so given 54% of India faces high to extremely high water stress, 54% of India's groundwater wells are decreasing. So it is a constant worry. And I recently, during my I had a Fulbright fellowship in India, and I completed work on groundwater level depletion in Delhi metropolitan area, which shows again that the groundwater levels are decreasing at a very steep rate. And how does that translate? More than 100 people live in areas of very poor water quality. So not only are we facing scarcity in water, in freshwater availability, but this is going to directly affect 100 million people. So these are the regions which are densely populated. So we cannot ignore this issue in hand. So I hope I have established the importance of the issue. So the topic I am looking at is examining the role of variability in regional level seasonal precipitation and land use land cover change on groundwater levels. So my presentation consists of two papers. One paper was published this year, and the other paper is under review. So I'll combine the results from the two papers. So bear with me as I go through a few graphs and maps. So the groundwater data, recently several publications have come out on the groundwater trends, thanks to this recently available data from the GRACE satellite mission, Global Land Data Assimilation System. And from the GRACE satellite mission, we can retrieve the terrestrial water storage change. And then we can also, from that, we can get the total water storage change, the terrestrial water storage change, and the total water storage anomalies. This is available from the period 2002 to 2016. It's not available beyond that. But this satellite data, the data from this satellite, when it was first analyzed at the global scale, it showed certain regions of the world undergoing the maximum groundwater stress. So this satellite is able to extract information about groundwater levels. And it showed the Indo-Gangetic Basin as one of the most stressed regions of the world in terms of groundwater depletion. And here's the equation by which we calculated the groundwater during this time period. We also took into consideration the precipitation, which we looked at the regional level precipitation available from the Indian Institute of Tropical Meteorology. These are homogeneous rainfall regions, and it's a very widely used data set for monthly rainfall patterns across the Indian subcontinent. It has been derived from 306 uniformly distributed stations in India. The only shortcoming of this data set is that it doesn't have presence over the Himalayas. So it's south of the Himalayas, the Indo-Gangetic Basin, but it does include the northeastern region, which is, as Professor Matsumoto mentioned in his talk, that it's a hilly region. It's one of the heaviest rainfall regions. So therefore, through this talk, I hope to show the interaction between the highland lowlands, the groundwater depletion, the changes in land use land cover on the groundwater levels. And then finally, the land use land cover change data, which were acquired from the MODIS land cover, which are available at a spatial resolution of 0.05. So not the finest resolution, but we are talking about a very large area. The land use classification was derived using supervised classifications with ancillary information, which made the classification more accurate. The work was done at the seasonal scale. So 4 seasons were taken into consideration: the winter, which includes January to February; summer pre-monsoon, which is March to May; the dry season, southwest monsoon; the wet season, the main rainy season, June to September; and then post-monsoon, which is October to December. These are the 4 months which are in conformity with the seasonal classification by the India Meteorological Department. Once we got the rainfall data, we used linear regression to calculate the trends in seasonal precipitation, annual land use land cover change, as well as the groundwater data. And then we use the hypothetical test, the p-values, to judge the significance of the trends at the regional level during the study period. And finally, because the ultimate objective is to not only look at the trends in groundwater levels, but also to look at the impact of land use land cover change and precipitation on groundwater recharge and depletion. So therefore we use correlation analysis at the seasonal scale between as groundwater as an independent variable and the other 2 as the dependent variables. So here are my results. First, I just want to show the all India level. So as you can see, the all India level trends in groundwater 2002 to 2014. This is from my first paper, which we had already published, which we had submitted and published. And you can see that there is quite a bit of variation at the overall, at the all India level. We also did get the data for India, Pakistan. So you can see the differences in trends. As you can see, there's a lot of variation, inter-annual variations, as well as within intra-annual variations. So not only between years, but also within the years, there is definitely a seasonal variation in the groundwater levels. And here is a very simplistic visualization of a relationship between rainfall and groundwater. So what's interesting is that certain years when we had heavy rainfall, it was not followed by a high groundwater recharge, and in certain years heavy rainfall matched with high groundwater recharge. So what this shows is that all India level does not necessarily reflect the local level variations. And as geographers, we are spatial scientists, we are into spatial heterogeneity. We wanted to look into the local level variations of rainfall, land use, land cover change, and groundwater levels. So when we get into the regional level, these are the 6 regions which are the homogeneous rainfall regions of IITM, Indian Institute of Tropical Meteorology. You can see that there is a lot of variation within these regions. So these regions, they all have the distinct characteristics which need to be studied separately. So the first one was a distribution of the 5 climate regions. So this just shows the change in groundwater level trends. So as you can see, it's a coarse resolution satellite image data, the groundwater data. But what it does show is that, as I showed in the first few maps, is that there is a very steady decline or a steep decline in levels of groundwater in the northwestern India, which is the area where green revolution was most predominant. There's a lot of groundwater taken out for irrigation agriculture. So here is the all India level trends in groundwater storage. And this here is something I would like to point out more, is that what we were surprised to find is we of course expected northwestern India, this region, to have high trends of groundwater extraction, so groundwater depletion being very high, so groundwater levels going down, which completely makes sense. But what we were most surprised by was the northeastern India. This is the region where Dr. Matsumoto's lecture was out here and parts of here. This is the region which is one of the heaviest rainfall regions of the world. But we found that the groundwater depletion was very high in these regions. And one of the reasons we could think about was that as here it is related to agriculture, irrigation related agriculture. In this region, we found one of the possible reasons we could look into was the type of topography. So we are talking about very steep mountain slopes, rocky areas, not much infiltration of water into the groundwater table, as a result of which there's a lot of water lost there. And here's a trends in regional level precipitation. So yes, in India, there are most of the northern parts, as you can see here. This is west winter, this is summer, monsoon, and post-monsoon. The northern regions are actually experiencing declining trends in rainfall patterns. Interestingly, we just got a minor revision on a paper, which I can talk about, is on thunderstorm activities in India. And we are also seeing a decline in number of thunderstorm events in the Indian subcontinent. So this matches up with our results. And then finally, we calculated the trends in the different types of land use land cover. So we took the main types of land use land cover we took into consideration was deciduous broadleaf forest. Those were the main land use land cover types that came out of the analysis. Mixed forest, grasslands, croplands, urban and built up, and barren and sparsely vegetated. As one can see, if you go through this, is that most of the land use land cover changed between this period 2001 to 2016. Most of them were statistically significant trends. That's one aspect. And then we also saw that in most cases, there was quite a big positive trends in the case of urban and built up areas and croplands. And a declining trend mostly in grasslands, barren or sparsely vegetated, moderate increase in mixed forest and deciduous broadleaf forest. Based on that, here are the seasonal correlation coefficients across the different regions. Overall, you can go through this in more detail, but what we found was that there was a negative correlation between urban built up, which you can see out here, and the groundwater levels. We also saw a negative correlation between cropland and groundwater levels, but that was not the patterns were not similar through the seasons or through the different regions. So for instance, in the case of peninsular India, it was not so clear. The relationship between urban built up and groundwater levels was not that clearly significant or a clear pattern emerged. But in the northern areas, there was a negative relationship between the two. It's obvious that urban built up areas lead to the increase of impervious surfaces, which means less recharge, less infiltration. Increase in cropland means there will be more water which is being taken out for irrigation purposes. What is to be noted is that it is the drier areas which experienced a stronger correlation between cropland or urban built up areas and groundwater. So there's more groundwater being extracted from the water table. So finally, my conclusions and discussions. So the trends in the seasonal rainfall of the region scale show substantial variability. The peninsular region also experienced declining trends in rainfall during all seasons except the monsoon season. Various land cover categories, of course, croplands and urban built-up areas were the two categories which had predominantly negative correlation with groundwater, which completely makes sense. And then the patterns where there was variability in terms of seasons as well as the different regions. To bring it back to the point is that this is the percentage of area equipped for groundwater irrigation across India. Unfortunately, there's no clear data set available for to look at this relationship more clearly, but I just found this from Siebert et al. 2013, their publication, this map, and I just wanted to show this map just to bring home the point about why we are seeing this strong correlation between groundwater and cropland and urban areas in the northern regions. As you can see that so the highest the areas with the highest percentage of groundwater irrigation is in the north and central India. And if you remember the first maps I showed, it actually shows in the future it is central India, the Deccan Plateau out here. That's where is going to be the higher water stress. Water stress is going to increase in this area. And finally, the correlation coefficients between urban built-up and croplands were predominantly negative, which makes sense in the entire northern and India and northwest, north central India, which makes sense because this is the area which is highest population density as well as rainfall stress, water stress is higher there. The results of this study is in conformity with previous research on this topic about groundwater and land use, land cover change and rainfall. There have been several studies done in other parts of the world which shows similar patterns. How does this tie back to the overall? So climate change and water stress. So why it is important is that the climate change will profoundly alter the future patterns of both water and water availability and use, especially freshwater availability. Water stress is between 0.4 to 1.7 billion in the 2020s and between 1 and 2.7 billion in the 2050s. These are some of the projected. And it's only going to increase even further in the future. And other than climate change related reasons, global water stress will be aggravated by other factors such as economic development, population growth, policy implications, and this is particularly important for the developing countries in the global south, which will be impacted by climate change due to their greater vulnerability. On that point, I hope I was within my time limit, and I'll stop here. Thank you.
Excellent. Thank you very much. Again, Dr. Senroy, I appreciate. Next, we are going to give the floor to Professor Panjak Kumar.
Thank you.
Okay.
Thank you very much, Professor Chair. Let me share my screen. So thank you everyone for giving me this opportunity to share my work on basically related with this topic, the crisis in between highland and lowland. And I thank organizer of this IGU India International Conference 2020 on global to local sustainability and future earth, Department of Geography, Faculty of Earth Sciences, Udaipur, and my chair of this session and all panelists. I thank you all for having a very nice input in this session. And I will start with my work, which I have done basically on GLOW phenomena in Himalaya, glacier lake outburst flood. But in a starting, I would like to have a very strong statement here that the earth climate is changing, but the change is not everywhere similar, and with a varied rate of change we can notice. And Himalaya is also not exception. It is also being affected by the seasonal shift in rainfall and temperature. When we plot the data of the rainfall and temperature, we clearly see that there is an increase in land surface temperature in the whole Himalayan region, but we cannot find a clear-cut change in the rainfall pattern of the continent. But definitely there is a sign that the extreme events are pointing us that there is something where the increase in rainfall or the variability is increasing, like from a standard deviation. So from mean, the rainfall patterns are deviating much more than they were deviating earlier. And we are quite familiar with now in last 10 years, 20 years, we see that there are increase in number of extreme events in the Himalaya, and which are affecting our lowland people quite prominently, and the magnitude of these changes are also very high. So a scientific evidence of by IPCC, which states that 97% of climate scientists agree that climate warming trends over the past century are very likely due to human activities, and most of the leading scientist organizations worldwide have issued public statement endorsing this position. And if we'll search as we go for publishing our paper, we see that most of the scientists are working in this direction, that there is a climate change and the Himalaya and other mountains of the worlds are being affected more than the other areas. And the IPCC report of fifth IPCC report also endorsed this statement. We see here the surface increase, the temperature increase in after 2000, and we have the projection of this IPCC, and we see how the projection is increasing, and for all scenario A1B, A2 and all, we see that the increase is projected quite high. So we have to be worried. And what these increase are contributing to us, if you see the spatial pattern, it looks like this. That everywhere we see that the red segments, red portions are increasing, and very few places on the Earth's surface we have. If you plot the average temperature, it has been taken from the fifth assessment report, that it clearly points out that the climate change is happening, and that is why we have to worry about our mountains. The climate change and glaciers have a typical type of relationship, and because of the exposed surfaces, greater absorption of heat by exposed surfaces taking place, which is contributing to increase in temperature, and this temperature increase is resulting into the melting of the snowpack, and this melting of the snowpack is decreasing the area of the snowpack and ice, which is again this exposed area or the surface are a very suitable ground for creation of glacial lakes, and these are also a probable area where the heat are being absorbed, and so the surface temperature are also again increasing gradually. So the snowpack decrease, and subsequently this cycle is going on, and we have more surface temperature increase in the mountain, and we are noticing more glacial lakes coming up in the Himalayan mountain, especially in my area. The shrinking of glaciers is everywhere in the news. So this is coming, and we can see from the images which NASA has given, placed on their website, that it's a clear indication how fast the changes are taking place, and how the glacial lake are coming up at the snow out position where the melting is taking place, and these glacial lakes can be a danger for the riparian basin for the low-lying people living in the valley regions. In the mountain, we have several examples like vanishing glaciers in the Glacier National Park, Montana. We have from 1984 to 2015. The same case we can see here, Arctic Sea ice coverage hits the record low in 2012, and still the melting path is going on. So you can see here in 20 to 30 years, we have the warming has impacted in such a manner that almost 20 to 25% of the ice mass has been vanished. The older this Arctic Sea ice is also declining here. The same period we have taken, and all the images are there on the NASA website. From there, I have taken this one. How see here how the small lakes or supraglacial lakes or above the glacial lakes are being developed because of the melting. So these glacial lakes are basically develop at the ablation zones. And you can see here the morphology of glacial lakes, how glacier accumulation takes place, how the glacier melting takes place, and that the spur regions, in the spur area where the terminal and the lateral moraines exist, they provide a suitable ground, and melting of the glacier, receding of the glacier gives a space, suitable space to form the glacial lake in this region at the point of the outlet, and these glacial lakes can be a danger in future. So there is a need to monitor them. So my objective was to see where the glacial lakes are lying in the Himalaya in my study area, how many glacial lakes are there, how the number are increasing from past to till now, and which one is potential glacial lake which can be a threat in the future. So taking analytical hierarchy process, we identified 10 to 50, 10 indicators, factors, those are contributing into making these glacial lakes as hazard prone. And so we have here Imja Glacial Lakes also. Such a big lake has been created in the mountain. We have so many examples from the other parts of the world, but I will focus to my own study area. Here is from Colorado River Basin, the Greenland, the Peru regions. Everywhere we find that the several glacial lakes are coming up in last 20-30 years, and their size is increasing very fast. The volume of the water is now becoming substantially high, and they can pose a threat to the lower basin, river basin area where the people are living, habitating, doing the agricultural activity in very close to the river channels, and they can feel this threat. So in the Hindu Kush Himalaya, the area includes the largest glacier ice volume in the world and the perpetual snow outside the solar regions. The process of glacier retreat gives birth to the glacier lakes on the plain surface, beneath or at the front and next to the mother glacier. Such glacier lakes are often considered proof of changes in the glaciers. So it's a climate indicators also. If there is something happening in the glaciers, we can see these are the real indicators of the climate change. This is my study area. I have worked on in the Lahaul Spiti regions of the Himachal Himalaya, that is Trans-Himalayan region. Crossing the central Himalaya, we get the Trans-Himalayan region touching Tibetan Plateau area. So in the Trans-Himalayan region, we have taken these two Lahaul Spiti, a bigger district of the Trans-Himalayan region, and almost all of the year for only 4 to 5 months, it's remained devoid of this snow cover. Otherwise, it's completely full of snow and all ice. So in this region, we have taken the satellites image definitely for doing this study, and we started our study from September October 1976 to this 2019 data. Even we have incorporated some of the data of 2020 also, which is freely available on Earth Explorer, and we downloaded it, we pre-processed it, we resampled it. Like 80-meter data are there for Landsat MSS, so we resampled it, and then we tried to identify the glacial lakes in the region. We took this methodology to map the region and to find out which glacial lakes are more vulnerable in future, so that those glacial lakes can be monitored regularly by the government machinery, and we can manage them efficiently by using some techniques. Okay. So we have taken the glacial lake proximity, drainage type, area of the lake, lake growth, slope of distal, then freeboard level, tectonic lineament, ratio, width to height, width of the crest, then the geomorphological factors. And we used analytical hierarchy process, and we tried to come out with how many glacial lakes are there in that area. First, we tried to do the inventory of the glacial lakes, and these are the latitude and longitude positions of the glacial lakes. Around 196 glacial lakes we identified in 2019 in my one small districts of Lahore and Spiti. So these 196 glacial lakes we identified, and we have given the altitudinal zone-wise location of these glacial lakes. And by using these criteria, the stain criteria, we came out with the conclusion that there are 3 or 4 lakes, those come under the high vulnerability category. So those glacial lakes has to be regularly monitored by the government machineries, and we tried to see their behavior, and we see here that the 2 glacial lakes, lake number 170, that is the Gepangat, and the lake number 171, that is Samudra Tapu Glacier, their size is increasing very substantially. And in 1976 there was only a small glacial lake which has been more than uh, 10 times larger than their previous one, which we noticed in 1976. So such a increase we are noticing here. And if there is anything which is happening at the moraine dam location of these glacial lakes, if there is some disturbances because of tectonic active Himalayan region, anytime the earthquake can come, anytime the landslides can happen in this region. So if something is happening and water is overtopping from these lakes, that can be a huge disaster in the low-lying region. And we have experienced this one in the past also. So this is one case study, which this is the Parichu Glove in 2005. And we see here that the whole village was basically washed out because of this Parichu lake outburst. The Parichu, basically this lake is situated in Tibetan region of China, but the river flows in the Indian side, and it meet into the Spiti river. First, it is known as a Parichu river, then Parichu meets to the Spiti. Spiti after some time meets to the Satluj river, so become the part of the Satluj river. So in this region, we have noticed some of the damage, but unfortunately, there was no damage of the human lives, but we have damage of the animal lives, houses, and roads, bridges, crop damage, horticulture damage. So we estimated that total 186 million US dollar loss, as per the government record, was done by this Parichu lake outburst. And all agricultural lands, roads, and for certain around 5 to 10 kilometers of the roads were totally washed away. The bridges were washed away, and alternative roads, because this is also an area where we have the military establishment. So providing them, the military, frequently materials to sustain them, supply and all, it is very important to maintain these roads in that region. But if such type of events are happening frequently in the Himalaya, it is going to affect our supply system to our military bases and to the people living in that region. The crops were stranded into the field because these are the regions where we have off-season vegetables, and those off-season vegetables come to the market in big mandis where we sell these produce near about Simla. And so all these regions where all these crop produce will remain stranded for 6 to 5 months. So a big loss happened to these farmers. And there was also, because of this huge siltation and all, our Naphtha Jhakri, this dam, remained closed for 3 months because the turbine were not able to operate. And we can see here, we mapped, like in the lower part also, we tried to see what is happening in the lower part from Sumdo to Poo. Sumdo is a military establishment of Government of India. And then from Sumdo to Poo, we have seen how many damages we have noticed in between, from Poo to Kharo, and from Kharo to Jhakri. Jhakri, where we have the Naphtha Jhakri hydropower project, and that was shut down for 3 to 4 months. So the whole region was basically devastated because of one single event of the events of Glove, this Parichu Lake outburst flood. But n number of around glacial lakes are there in Himalaya, and anyone can pose a damage or threat to the low-lying basin. So a very good relationship we can find here, that there is, if something is happening in the mountain at the top, it is going to affect the people living in the lower valley region also. So this is my observation about this one. Thank you very much.
Thank you, Professor Kumar. I appreciate your presentation. If you please stop sharing your screen, we'll
Yes.
continue with the program. I would like to ask Dr. Nadani Singh.
Oh, see, is not because some of the urgent work, she could not join us today.
Is somebody else presented instead?
Maybe this Ink Amdong Sandong can go for sharing his thoughts. We can invite him. He is from Mongolian Academy of Sciences.
Okay, perfect. Thank you.
May I request on behalf of the chair, may I request Ing Amlong Sangdong to go for his presentation, please. Maybe there is some issue of connection. So Bhamar, we can go for
Yes,
taking the question answer. Yeah.
Sir, we got the two questions from the audience. First one is how the residing glaciers and their impact on mountain ecosystem.
Okay.
Yes, sir. And second one, how indigenous knowledge is useful for the mountain ecosystem for conservation.
Okay.
Yes.
So I think so. The first question is to me, and the second question is to the chair, Fausto Sarmiento. Yes. And professor can also give his input in the first question also. The first question is basically a general one, that how the glacial the changes in the nature of the glacier is going to affect our the mountain ecosystem. I would say it is not going to only affect the mountain ecosystem, but it is going to affect the whole ecosystem related with the mountain, like the plain area also. As we know that in India and in Himalayan mountain system, we have to depend most of around 30 to 35% of the area of the India is directly taking water during the after the monsoon for cropping system from this melting of the glaciers. So if there is less glacier available in the mountain, it is going to have a less amount of water available for our cropping system. And it is rightly said that Indian subcontinent is dependent on the good availability of the water from this Himalayan mountain. So even in the Himalayan mountain, we have big cities now coming up. We have some capital cities and some tourist cities are there, and the tourist destination are increasing in the Himalaya. They get their urban water needs from these glacier melt waters. So after the monsoon season, the supply of this water to these urban centers are also from these glaciers. So if the glaciers and small glaciers are melting nearby regions, we have to fetch water from the long distances, and that will incur a good amount of money on investment on infrastructure. So and we are noticing it, like the Simla and Manali and other regions are getting affected by during the summertime. Because of the high concentration of the tourists and demand of the water, the supply is being affected. So we are now noticing this one, that not only this one, but not only the agriculture, but also for other purposes. We directly take the water from the river channels, and those rivers are being fed by the melting of the glaciers. So any change in the river regime or the melting of the glacier is going, if any change in the melting in the nature and the health of the glaciers are it is going to affect the river regime also, and which is directly going to affect the supply of the water in that region.
Sir, another questions.
Professor, you unmute yourself.
Okay. Yeah.
Yes, thank you very much for your answer. I think it was very clear. Just touching on the second question that was referred to, how environmental conservation in this mountain system can be better achieved, I would like to mention only 3 points. One is in relation to scale. As you all know very well, geography, being the science for studying spatial distribution, relies mostly on scale. And so if we are planning to develop conservation measures for mountains, we have to verify at what scale are we going to work. I am actually now working in the Andes Mountains, dealing with the need of establishing micro-refugia of biodiversity. These are small biological or ecological reserves that are managed by the local people. And we have had very good success in establishing these initiatives at the local level. Second point that is very important is actual international collaboration, particularly in the area where you are studying, the Himalayas. It's very important to find ways in which the different boundaries between the neighboring countries can be secure and can be protected. And finally, the third important dimension is actually a new look at conservation priorities, particularly now that we are starting the decade of the restoration ecology. This has been called for by the Convention on Biological Diversity. For the next 10 years, we will be celebrating restoration ecology. That means that the denudated slopes of the Himalayas may eventually could actually be the object for reforestation or even afforestation projects. And that will definitely help in mitigate some of the impacts that we now have in the conservation of mountain systems. So summarizing, the efforts of mountain conservation would be at the adequate scale, whether it be local or national or even global level. The second point would be important collaborative approaches that different countries can take in establishing these ecological corridors of transboundary conservation programs. And finally, is that looking at protecting what is there is not enough. Remember that sustainable development now is being framed under the conditions of regenerative development instead. So what we have to emphasize in conserving mountains is the possibility to bring back all of the original forest cover that had been actually present there prior to the colonial exploitation. And this is actually very important. Thank you for this question. Made me think very much that the future is bright for conserving mountain ecosystems.
Professor June Matus Moto, am I audible?
Yes, sir.
Please put your view on the panel discussions on the mountain ecosystems. For the summarize, please summarize.
Oh, yeah. I personally, don't hear, but anyway, glacial growth is partly due to the global warming, as Professor Pankaj Kumar mentioned. So not only such glacier, but also the fall temperature or rainfall situation, the mountain regions are now, I think, changing. So in some sense, even in natural sense, in particular for the ecosystem in the higher altitude are kind of in crisis or something like that in conditions. So maybe human beings need not to accelerate even, maybe there such a change will not be avoidable, I'm afraid. But anyway, in the global scale, maybe of course we should struggle more on how to stop our global warming. But in regional basis, maybe at least we should not try to conserve our nature as much as we can. And as the chair mentioned, we should to try to restore the former natural conditions as much as we can. So sorry, this is my opinion. Thank you.
Professor R.V. Singh, sir. Respected Sir R.V. sir. Am I audible?
Pawar, Professor Singh is somewhere, is
Okay.
busy, so he cannot give remark right now. So we request chair to close the session.
Yes, of course. If that is proper, let me first congratulate the presenters tonight. I also would like to congratulate all of the organizers, the moderators, who have taken the time dealing with this very interesting Zoom meeting. As Professor Sen Roy has stated already, it's quite late here in the United States, but it's a gorgeous day down in India. And I do think that this is precisely the starting of the conservation efforts in the prospect of better mountain management. As I always say to my colleagues and friends of the mountains, we not only need to know the mountains from the science, but we also have to know mountains from our hearts, from the arts, from the humanities. And so I would like to close this very interesting presentation and the panel altogether with an invitation for us to consider that mountains are not only not in crisis, but they are now considered to be a very important socio-ecological landscapes that had to be dealt with these two different approaches: the consilience of transdisciplinary research and the impetus of the new generation of researchers that bring about these new technologies, the new applications of geo visualization and geospatial analysis to better understand what's going on in our loved mountain systems. Again, thank you very much to everybody for your kind attention. My congratulations, heartfelt, again, for my colleagues in India, with best wishes for the continuation of the hard work of the IGU Mountain Studies Commission. And of course, the warmest wishes for the holidays from this part of the world to yours. Happy holidays, everybody.
Thank you, Professor. Thank you.
Sir, 1 minute. Thank you so much, respected dignitaries, Professor Fausto Sarimanto and June Matusmoto, Professor Suresni Sen Roy, Dr. Pankaj Kumar, and Professor Sandang Amlangam, Mongolian Academy of Sciences. Thank you so much for the taking giving a valuable time to contribute in the meet, and we are in them thankful that you attended our event. We hope you enjoy the experience and looking forward to meeting you again next time. I hope you next time in meeting physically. Thank you so much to all respected dignitaries.
Thank you very much.
Thank you.